Alright, took too long to get started. I had to shave. Alright, let's get it. Where were we last time? What? Oh, I didn't do it? We got right here. Yeah, because define null 0 is the same. That's just an expression statement for saying 0. And it's the same as that's included in. It seems like that's transitively included. There's like some basic level library with a bunch of shit that all these other standard library header files use, because every time I include like every time I include anything in the standard library, I get null. It always includes it. It always includes uint 16, all of it. I don't have to do C standard int. I could do, actually I might. Hold on. Yeah. Yeah. Even uints and whatnot, they say to include well, maybe no. I was thinking maybe C standard int is included in IOStream, but I don't think it is, because we've included both before. So maybe some things are transitively included. I don't know. But long story short, there's null. We shouldn't use it because it's basically explicitly using just saying 0. And if we do that, an int pointer, just say that, and I do null, well, this is the same as doing 0, which sure is assigning it, depending on the architecture, whatever, or sorry, it's evaluating, or hold on, what is it doing? It's saying the value of null pointer I think the point is that on some architectures, 0 and null don't work. Null pointer, however, checks our architecture and returns the proper value. The value that creates a null pointer. Because null pointer isn't a null pointer returns the address that pointers can't point to, I think. It basically, it returns a null pointer. So we could do the 0 address, and it works just like null works, but not on all architectures, so my program might not work everywhere if we do null or 0. Plus, if we do 0, it's weird because we're using the only integer, because this is an int. I mean, we can... Alright, well, 0 is a fucking integer. So, if I'm using an integer here, it makes you think that this guy takes a parameter, or takes, it can be initialized with an int. But it can't. I can't put in 1. It's that 0 happens to be a special value when used in this context. Just like int pointer is not int data type times an object that doesn't yet exist. It is a symbol that is used in a different context to create its own unique operator. That's why it's, in this case, it's the dereferencing operator. Or rather, in this case, it's the pointer definition operator, maybe, I guess. Hold on, I have a Walmart order, and it has substitutions going on here. Is it the parsley? What the fuck? Oh, okay. Bro, there's no fucking way. Alright, that's fine. Holy shit, dude. Yeah, I was getting Quaker oatmeal because it doesn't really have any bullshit in it. It has natural flavors, but whatever. It's okay for now. It's the best I can do to eat it. In a 20 pack is like $5, but then I was getting charged $9. I'm a broke ass. I can't do that. And it was because the thing was determining it went down to the 8 pack instead of 20 because I guess that's the next biggest size, and it was buying 3 of them so that it exceeded 20 or at least hit 20. That's just too much. So I said, fuck it, dude. Fine, 2 8s for 5, same price but minus 20 per. Oh my god, yeah, minus 20%. It's whatever. It's fine. It's 2 weeks of oatmeal. It's fine. All right. Yeah, on modern architectures, 0 is, but on others, not necessarily. So, ah, so it seems like 0 is okay. It seems like 0 seriously is fine. Okay. So they say why later, because it really doesn't seem like 0 or null are actually bad. I thought that it was as bad as I thought that it was bad, but yeah, in the context of a pointer, just like this symbol in the context of 2 ints is the multiplication operator, but in the context of a data type and an object type, it's a pointer declarator. I don't know, pointer declaration operator, pointer definition operator, maybe something like that. I guess declaration, right? Because it's not you're defining it. You can't declare it without defining it. It's a variable, so it's not like a function where you can declare it but not define it. Okay. All right. Seems like it's okay, but I guess we'll find out later. Pass by address. Oh, that's in 3 or so chapters. Pass by address. Oh, is that different than pass by reference? Oh, can I? So a reference to something versus. Is that something that I'm going to be learning soon? Is it that late? There's no way. I mean, I guess I could pass the value of a pointer and then change. And I can dereference that without actually having to update the pointer itself. If I want to update a pointer, I have to pass a reference to the pointer. But if I want to change the value the pointer is pointing at, like, I don't care. Sure, I think so. Debating if I need input output stream or not. Okay, so we have an int pointer, np, or we'll just call it IP. Or sorry, it's not pointing to anything at first. Sure, it's just null. All right, and then here we'll do it in this order. Sure, we'll just do void set IP okie doke, and all we do is we take fuck. This is or hold on. In x5, sure. This guy gets the address of x, and this guy takes init pointer. Yeah, sure, we'll just call it IP. Why not? And then we pass it this value, and all we're doing is we're saying dereference IP is now 10. That's it. And we're going to call set IP. Cool. And output X. Oh, well, oops. Well, whatever. It's fine. We know that X is 5, and then eventually. Guess I should have just copied the line. Cool. So I can pass the value of the pointer without having to pass the reference of the pointer. And What was the point with references? Is it that? Oh, the point is that all the values can be stored in a CPU register. It's just that with a reference, you also then have to go into the memory. So not only are you going into the CPU register, you also have to go and find memory. In this case, it might be faster actually to just pass by value because we're simply passing a little, basically an integer, I think, a hex integer of this address, and we're just changing that. So we copy that number, and all we're doing is dereferencing the address. We don't give a shit if we're actually using the real pointer or not to get to it. We're just using the address that it's holding. It's fine. So, cool. Alright, favor references over pointers. Why? Just because safety? If I have a reference to something... if I have a reference to something, then... I mean, I guess it's bound to it, so if I change the reference, it changes the thing. And only that thing. We might have dangling references, sure. So we can use const references so that they have independent lifetimes though, so it could be dangling. So in both cases, whenever the dangler dies, you need to be careful. And make sure to... Well, I mean, I guess in that case, make sure the reference doesn't outlive the referent. Yeah, because if a reference can only be bound to one thing, and then when the thing dies, it's not bound to anything, but it can't be rebound, it's bound to where it was, then when the first thing, the referent, is gone, then the reference has nothing to use. We get undefined behavior because it's getting whatever fucking value's there. Maybe it's the same, maybe it's different. Maybe memory is slowly shifting over time, so instead of getting 662, you get 624 or 462. So you get a piece of it, but not the rest because a value on the side of it changed. So your big value is now slightly inaccurate when you get it later. Okay, let me get music going. Okay, this is good. So the point is that so far we don't have const pointers. We don't have pointers that are initialized to point to something and only that ever. Because then, isn't it just a reference? It only gets the address of something and then... Pointers hold a piece of memory, an address, not the actual object. So conceivably, if a referent or if the referent, so some object int x, gets moved in memory for some reason, then the reference should still be bound to it, I think, if it follows the object. But if a pointer can't follow moving targets, and it's just looking at an address and it's just staring here, well, if the moon moves, you're staring in the wrong place. You have to follow the moon. And if we make it so that, hey, we can't blow up the moon with a pointer or with a reference, but we can blow up the moon with a pointer, then maybe pointers are better used to target hard things, like things that are so far and tiny that we can't bind to them, or things we can't bind to for some reason. Like so far it seems like we can use references in all the cases instead of pointers. So I meant to do a self-test last night, but I fucked up. I was getting sleepy, and then I brushed my teeth early, and then I just wimped out, and then went to bed. I mean, I watched Breaking Bad for a while, but I was just too sleepy. I was not alert enough to do programming, but alert enough to watch a show, which is probably just an excuse. Alright, pointers have additional abilities of being able to change what they're pointing at. Yeah, sure. But, yeah, those abilities are dangerous because if something we didn't expect, like, there's no way something can change what our reference is bound to. So it's always going to affect the shit we know that it's going to affect, unless there's one case where it doesn't, where the thing, the reference is dangling. The thing it was bound to, the referent, is now invalid, or somewhere else, and it didn't follow it or something. But I'm gonna just say it was destroyed. So, like a dog coming home to the dead owner. Now the dog, we have a dangling dog. So we gotta fix that. So what we do is, the second the referent is gone, or we'll just make it so that the reference dies first, I think. I think that's the strat. Or at least at the same time. That way you define the thing and the reference to the thing. You pass the reference and stuff around, and then boom, they both die at the end of the same scope. So scope to a little block here, boop, reference, oh, and they both die. Oh, you go and use them, do crazy stuff, and then oh, they both die. And then you're only affecting that object in memory instead of fucking around with other stuff if you accidentally manipulate it. Oh yeah, true. Because if we have a null pointer and we dereference it, then the program will crash. So it adds the requirement that hey, your pointer like. You use it because it's safer to crash the program. Like it's safer to slam the door shut and startle everybody than it is to break a vase in the house. Like if you have to, just close it, restart, and we'll fix the stuff. Don't break the vase. Don't go somewhere else and do something that you shouldn't. A pointer opens something, you open the door, don't open the vase. It's okay to open the door. It's gonna crash the program, but it's better than messing with permanent things. And if a pointer's changing at something and we say, hey, if point at this, otherwise point at this, then if that we have to now check multiple things to make sure that those are both valid cases. Or like, so what do we have to do? We have to, and the strat for making sure that pointers are valid is, I guess, to point it at null. Remember that whenever a pointer is pointing at something, and that something is going to go away, to make the pointer point to null before then. So maybe feels like there's some extra baggage. Like if I have a pointer pointing to something that I've passed somewhere else, I'd have to see it play out. Honestly, I can't really think of an example right now. Oh yeah, cause yeah, okay. So this is undefined behavior. We have a pointer p Then in inner scope, we create a variable, an integer variable x, and we assign p to look at it, to point to it. Then x is destroyed, and then we check to make sure p isn't null by checking if p, because it will return, pointers return false or true if they're pointing at null pointer or not. Excuse me. So let's create a repo. I don't know where it went. Wait, bro. Online only. Hello? Oh, local only. Yeah, there you go. No? I don't know where it went, but. Yeah, so now if we output it, sure we get 5, because it happens to, that value looks like it's still there. Oh, I gotta keep my phone like that, it's fine. What if we... No, dang. I wanted to see if I could create... I mean, there's no logic to it. Well, I mean, I was hoping that if I created another variable in the scope, that it would create it, it would be created near the other variable in the same scope. Like if I looked at all the memory and I looked at all the shit created within one scope, I would hope that it wouldn't be fully scattered around, but that probably doesn't make any sense. Like I would hope that it would, the compiler would choose to put it all, or I guess at runtime it would be chosen to put it close to each other. But I can't exactly declare a variable in a scope and another variable in a scope and have them die at different times. So it's like, fuck it, next best thing is just right after scope, I guess. But no, because the idea was that I was hoping to create an integer, point at it, but then the integer is gone, and then I was hoping to get another value there. That way we can see, oh shit, the pointer 100% did dangle, because we saw that it went from pointing to 5, or the value at the place of memory it's pointing to is 5, it became 4. Oh shit. But it was still pointing at 5, so it means that it was pointing at something. The object was destroyed, but the value is still there. And then I just created another variable elsewhere. So, which didn't change anything. Okay. Yeah, so if I want to change an object, I can pass a reference to the object, or I can pass the address to the object to initialize the pointer and dereference it, or I can pass a pointer explicitly and dereference that pointer. But I don't think that would make any sense, really. Like it seems like you would just pass the value of the pointer. That way you're initializing a pointer, keeping the memory or the value, the pointer, I guess, the pointer in the CPU registry for quick access, and then we go there, and then we don't have to worry about anything else. Because otherwise, we have to still go there, because it's still a reference to a pointer instead of just being a pointer, and now we have to go into memory afterwards. We have to go into RAM. Yep. Yep. References can't be bounded. No, we don't have to worry about that. And they have to be valid. Oh, so the point is that when you create a pointer, you have to bind it to something that's valid. And if, or sorry, a reference, you have to bind it to something that's valid. And if that thing that it was bound to, the referent, dies, then you get issues. But with a pointer, you can declare it, or I guess define it, but not initialize it with an address, and it points to who the fuck knows where. And there's an issue if you dereference it then, because it's undefined behavior. And then if you assign it an address of something that's valid, but then later on you change that, or you assign it null, there are different issues here. Compared to a reference, when do we get issues? We bind it to something that's valid, cool. It fails if we do anything else. And then we can use it. We can change the values through the reference, pass them to functions, return them back. Alright. So there's no seeding problem. You don't have to worry about the chair being empty or full of something that it shouldn't be. It's only full of what you put in there. Unless it dies early, I guess. Yeah. The only way to create a dangling reference, it seems like, is so a dangling pointer, object, pointer. Set it to null, set it to something we don't want, dies, bunch of different ways to maybe do stuff we don't want. Compared to, or, well, null's fine, but set it to the wrong thing, thing dies, versus thing dies for a reference, and I can't update it otherwise. So, yeah, references are at least like 50% safer, seems like. Assuming those chances are weighted, those reasons are weighted the same. Fuck, I'm so sleepy. Plus the additional capabilities, which we don't even know yet. So, like a reference. Pass the value of something. Okay. Create a reference to the thing. Initialize a reference with our reference. Or right? Don't we get an issue or don't we get an error if we try and convert int to int reference? Oh fuck. So what is happening here? We have an integer initialized with value 5. We're calling passref, and passref takes a ref to an integer object. Oh fuck. Bro, why is it doing that? It's because I have to do this and not hold it down with C. Okay. Wow, so we actually can, huh? And so if I have an L value or an L value reference, and I assign it another L value, assuming it's a modifiable L value, then I am binding that reference to the L value, or I guess so. I'm binding the L value to, or the reference to the L value. I mean, we're assigning right to left, but maybe it's not the same thing. We're binding the reference to the referent. So if I have an object and I'm passing it to a function that is temporarily, or that has a local variable that is an integer reference, and I am passing it, copy assigning it, the same syntax, it equals something, and the something is an object, then I am initializing a reference with my actual object. Unless maybe the object gets converted. Let's find out if that's the case. Is it the case that that I can make this guy a Boolean, or yeah, if I make him a Boolean and then I pass him, do we just get an issue? Oh, well, the reference isn't gonna match the type. I mean, that's the proof right there. So we say bool and then true, bop. Can't convert from a bool to an int ref. So, but we can assign it like that. So we actually don't have to create a reference to something, pass the reference as a reference. Isn't that what I had to do? Or maybe not. Okay. So I have an integer, I have a reference to the integer, and I am passing a reference. I could just, yeah, like this is a waste. It's a waste to have a reference to this guy. This is an alias. It's like I'm saying, it's like I'm high-fiving my own hand or something, or like, instead of picking up my mouse and handing it to someone. I'm picking up a fucking plastic claw grabber to pick up the mouse and hand it to someone. Bro, get rid of the claw grabber. This is the claw grabber. So get rid of this shit. We only give a fuck about X and pass X, and that's it. We can pass X, and this is not saying that, hey, we're initializing this with X. Well, I guess we are. We're binding this reference to X. We're not just copying the value of X into it or anything like that. We're binding a reference to an L value. Oh yeah, because it's reference to L or an L value reference. Yeah. All right. Fuck that. Pillow's too big. Takes up too much of the chair. Dude, I have an Ingro now? Oh, fuck me, man. It's annoying. Okay. Alright. Yep, favorite references over pointers, sure. Oh, Jesus Christ. Yeah. So, I can take an object and pass it to initialize a reference. I can have an object and I can pass its reference to initialize a pointer to dereference it. Yeah, I could have a function with a pointer parameter, and then I can just pass it the address of the thing. So I mean, the point of a pointer is that it can be reseeded, I guess. All right. We can reseed a pointer to point to different things. I need to point it to this or this, or like, hey, we have a target and I need to look at that object, and then, oh, I reseed the target. Oh, we're looking at that one. I can set current target to get the address of whatever we're supposed to look at, like file to write, and then I have a target file pointer, and I set it to whichever file we're writing, and then once we detect an EOF character and end a file, then I can stop writing to that, and then set find the next file, and then set that file address to be target file. The address that my pointer will have. So favor references over pointers, because we don't want to accidentally reseed them. We don't want to seed them on the wrong thing, or we don't want to leave them unseeded. We don't want to dereference null. We don't want to seed them. Yeah, we don't want to change them unless we need to. We don't want to dereference null. We also don't want to dereference when they're pointing to something else. And also don't want to leave it unseeded. So we uninitialized, dereference bad. Dangling, dereference bad. Null, dereference bad. So there's a lot of cases where we don't want to dereference them. We want to make sure it's not null, it's fucking not dangling, and it's also actually initialized. And then what else? For a reference, it requires initialization. It cannot be reseeded, but it can still be dangling. So it has 1 out of 3 of the issues. Yeah, did you hear the joke about the null pointer? No, you wouldn't get the dereference. Right, here we go. Can we determine whether a pointer is null or not? Yes, just if the pointer, or if the pointer is equivalent to null pointer. Yes. Can we determine whether a null pointer is valid or dangling? Sure, we could compare it to a value that we know is not dangling, or is not invalid. But in a condition, we can, but we have to have that object. Yeah, it says there's no easy way to determine this, unless you know that there's an object, like a, well, I guess that's the point, dangling. Not pointing to the wrong thing, but, I mean, yeah, you can, right? you can check to see if a pointer is pointing to X, or we have a pointer in inside scope. We make him point at X, get X's address. But then after scope, X is gone. It's now dangling. I can't check to see if it's this. I can check to make sure it's not null. But I don't necessarily know what it's pointing at, and I also don't want to dereference it necessarily. I mean, if it's not null, is dereferencing it bad? I can do that and then just check what the value is. It seems like it can be complicated. Predictable, undefined, possibly undefined. Assign the address of an object to a non-const pointer. Address of an object to the same type of pointer. I think we're fine, right? Predictable. Hello? Yeah. Assign null pointer to pointer. That's fine, predictable. Dereferencing a pointer to a valid target. If it's valid, it shouldn't be undefined. Dereferencing a null pointer, undefined. Dereferencing a non-null pointer may be undefined if it's null or if it's dangling. But if it's pointing to something valid, it's okay. It just depends. We don't want it to be dangling and then accidentally pointing to something valid. I mean, maybe you have like a default thing. So like, maybe you have a targeting system and you have a pointer that points to the target you're looking at. But if it can't detect and then once it does, it auto tracks it. So like your cursor's looking here and the enemy's moving around, and once your thing locks onto it, it's following it around. But if you've lost it, then we don't want to shoot into nothing. We want to shoot straight. So we set the pointer to the defined straight. Bam. So it's sure it could be dangling because we've now lost the target. It was set to the target, but now the target has moved. So is it dangling? I guess so. It's not pointing to the target anymore. But then we can set it to be pointed to something that we know always exists, like our North Star. Dereferencing a dangling pointer, undefined behavior, because we don't know what it's going to get. Yeah, we don't know which thing. We don't know if it's going to go to a valid one or an invalid one. Yeah, exactly. All right, cool. Why should we set pointers that aren't pointing to a valid object to null pointer? Well, one, so we can guarantee that it's pointing at null pointer. Hold on. Maybe for the same reason you might have a comment in a an assert in a function, so that when it's called with a specific value that isn't handled right now but will be handled, you put an assert and append to it using the logical AND operator. You append to it enemy automatic riposte functionality not yet implemented, or something like that. So you put a failsafe, or not a failsafe, well, you put an alarm so that when you, oh my god, it's Thursday tomorrow and I get out at noon, let's fucking go. So that when you use it, you at least know what is happening. So either have it be valid and we know what it's pointing at, its expected behavior, or we point it at the ground. We plug the hot from a good call into the ground. We don't let it dangle around because maybe it turns out to be null when we don't want it to be null. Or maybe it messes up this value over here. So the targeting system is targeting an orc, but then when I kill the orc, the pointer is pointing at an object that doesn't exist. and then maybe I create a big ass object that's for like a dragon. It takes up a whole bunch of memory, and now the pointer was pointing at this little piece of memory for an orc, but when the orc died, there was only that same kind of area of memory left, and a big dragon was put in, and now the pointer's pointing at the dragon. And maybe the dragon's the fucking late game boss, or it's across the map. So now I've killed this enemy, and now my targeting thing is highlighting inside the mountain, like a Dark Souls thing, where like there's a little white circle highlighting, or in the middle of the enemy that you're targeting. Why is it targeting the mountain? Well, because there's a dragon in there. Okay. So that you at least know. I guess it's so that you get an error, so that your program crashes to prevent you from fucking stuff up. Anything else? Yeah, it's like an automatic shut off. Like I'm using, like if I'm building a VR headset one day and we're working on it and it requires a lot more power because the graphics are more intense, or maybe not because cloud computing is connected to it and the graphics don't require as much power because it's done elsewhere, and all we have to do is render it and it's already optimized and everything, so it's easy peasy. But pretend it's not, and it's just big ass headset and it's got a bunch of electricity going through it and whatnot, and we need to make sure that everything's good. And it's connected directly into the brain to simulate stuff better, to simulate scent without having to actually use chemicals and stuff, to put the sound directly in your brain or other stuff, or you're laying down and it's hooked up because you're unconscious. Well, you're laying down kind of comatose, unconscious, I guess we'd say, unconscious. But conscious in the game, I'm not sure how that would work. I don't know what you call that state. You're in another state. We would have some sort of system so that if the voltages start getting wonk, shut it off. Just like maybe Neuralink, where if you have, I don't know, the threads get too hot, the thermal whatever is exceeded or near the threshold, shut it off. Done. Kill it. Kill the program. We can't determine whether it's valid or dangling, and accessing a dangling is undefined. Therefore, we need to ensure that we don't have any dangling pointers in our program. And if we ensure that they're either pointing to valid or dangling, or a valid or null pointer, then we can use it. Oh, true. Yeah. So it's part of the response I said, but I was missing that. So that was the big idea, and also specific too. We don't want the issue of the lady who's plugging in the phone lines, the hotline operator, whatever, not hotline, the how may I direct your call lady. We don't want a hotline where people can get shocked by it when it's flinging around. But the real reason there is, sure, accessing it is undefined behavior, but so is accessing null pointer, but null pointer crashes the program anyway, so maybe it's actually okay. Because it's on purpose. Because every time I do it, it says, hey, you're accessing null pointer, and then it crashes. So maybe it's like an abort kind of thing, I don't know. But the point is that it then allows us to test if our pointers are valid or not. So if we make sure that our pointers are either valid or not valid, then all I have to do is check if it's valid or not valid. I don't have to do some extra check to see, oh, is it pointing at this or pointing at this or pointing at this or pointing at this? I just have to say, hey, is it pointing at null? No, it's pointing at what it should be. Or is it pointing at what it should be? Yeah? Okay, it's not pointing at null. We're good to go, buddy. Yeah, this allows us to use one test. We're removing the other cases. It's either pointing at something valid, it's dangling, or it's pointing at null. Well, if we remove the danglings by making sure that it's pointing at one or the other, anytime that it's going to become dangling, we make sure that it's null, like this, then it's either null or it's valid. Good to go. Pointers and const. Oh, What happens if we? Oh wait, yeah, but we could have a const pointer. We could have a pointer for const. I just don't know how to have a. I don't know if we can have a pointer that can't be reseeded, because at that point, is it just a reference? What's the difference between a pointer that can't be reseeded and a reference? Excuse me. I mean, a pointer can point to an L value reference to const, pointing to an R value. So a pointer can point to the same memory as an R value in cases. We use the pointer to dereference. I can get the. I'm having a hard time deciding if a const pointer is even useful. It's like a pointer that can't be reseeded, or a pointer that can't change the value but also can't be reseeded. I don't know. So the point is we have two objects and we have pointer initialized to point at x, and then we make them point at y, and then we dereference to be 7, and it's going to change y to be 7. Yeah, with a normal const pointer, we can change both what the pointer is pointing at or the value at the address. I need music to lock me in. No, not this. What happens if the value we want to point at is const? We just make a const pointer, right? Right? Unused, but it's fine. Yeah. So we have an object, a reference bound to the object, and a pointer pointing to the reference, which is bound to the object. And it's const, so we're cool. Now the question. Okay, so a const pointer means, one const at least, means that it can be reseeded. It's just that it's pointing to a const value. Okay, makes sense. Cool. Can't do that though because, yep, we're not holding a modifiable L value. What if we do we use L values as L value terminology for pointers too? Cool, so we still say L value, alright. And what if it's in const? Oh, so the pointer can be const. So, what happens if we do this then? Oh, so same thing. So we can make, just like we can have a constant reference to a modifiable value. That way we can't change it through the reference. We could also have a const pointer where it can change different, or it can be pointed to different values. The pointer can change, but it cannot update values via dereferencing because it's only able to point to constant ints. We can't set a normal pointer to point at a const value. Yeah, exactly, because then we could change a non-modifiable L value with a pointer. No, sir. Bro, autoplay, please. We good? Okay. Oops. Bro. Oh, this is it. Wake up. I need water. I think that's also part of it. All right. Okay, here we go. Yeah, const value can't be changed. It's the same shit as a const reference. We can't do that. We get the same exact error. What? Oh. Forgot the whole thing of what I was saying. And same thing here. Yep, it's a reference to a const guy. Ain't no modifying him through me, bucko. Like a tank. Sure, the healer can die, but I'm blocking it, motherfucker. Ew. Alright. Oh, that pimple in the ears. Ow. Alright. Man, what a song. Yep. Yeah, it's the same thing with the reference. Makes sense. Alright, we have pointer to const. Our pointer to a const value. I like the word const. I don't know why. It's just having two consonants next to each other. 3! Ah, I already copyrighted. Yep. Got a constant x, and we have a pointer to a constant pointer. Nope. Yep. Yep, can be reseated. Yep. But yeah, it's straightforward, obviously. Cool. I'm reading really slow today, but it's cool. Knowledge is still coming in just as good. Oh. Oh. I never would have guessed that. Not yet. Yeah, exactly. So you can't dereference it. Yep. Yep. No dereferencing a const, motherfucker. Because I think he's const. This is like attractive girl, unattractive girl. The fridge guarding the snacks. And says, hey, even though she's changeable, I don't know. I think she's not changeable. Therefore, I'm disallowing you from changing her. Or, well, I mean, you can't change her through me. You can't beat me to get to something like that. It's not a great example because we could just go straight to X and change it. Fine. Yeah, X isn't aware of this, so it's fine. One more. Last one. Man. Oh. Nice. Brunette baddie. Cool. So we can, yeah, pointers are super flexible. Wow. Whoa. Can't do this, nor can we do this. Double error. Not only is this pointer treating the value it's pointing to as const, so we can't modify it. We can't dereference the pointer to change this value because it thinks it's const, or it's treating it as const. Nor can we change what the pointer is pointing at because the pointer itself is also const. Cannot assign to a variable that is const. Oh, for XP. Oh, because so it seems like the wording for pointers is that we say the pointer is being assigned to something. It's saying that, hey, we can't assign. No, I think it's saying that's the point. It's saying that XP is the thing we're talking about. We cannot assign something to XP. So pointers are L values. So we can assign shit to it. It's const though, so we can't assign this to it. Much like if we have const int x2. Well, I assign him this. I can't assign him then this. No sir. Same error. Cannot assign an address to a const pointer. Now we're on the next one. So pointer to const, const pointer to const. Oh. Ow! I was trying to pop my toe, but I have a little ingrown nail action, I think. Happens every few months. Oh, it can be forward declared. Whoa. Whoa. I hadn't considered doing any forward declarations for these guys. Whoa. Granted, in this case, it would have to be, right? Yeah, we can only do it globally because if we have this guy defined within main, he is internal linkage. The linker will never see him no matter what the fuck we do. So he would have to be created up here though. So we could say, yeah, sure, why not, huh? Let's do a little header file action. All right, let's do extern int pointer const, a constant pointer. It's cool. It's like, hey, he's defined elsewhere. All right. But then we run him. Oh, it's actually fine. But really, even then. Oh, here's the issue. Here comes. It's a pointer to an int. I guess it doesn't, I guess it's dangling? Oh, well, yeah, that's what we need to do. I'm just curious what value it had. Motherfucker, dude. Ah. So this is fine, but the second we start using it, now it's unresolved. So it's like an expression statement for a pointer that doesn't actually even use it. Doesn't check it or anything. Interesting. Oh, it's actually okay. I don't need that. Because we already have a prototype in here, so it's gonna look, the linker's gonna look elsewhere and find this guy, so it's fine. We only have one issue, so it's fine. Do I have to put extra in here? Oh. Maybe extra in here? Oh! Okay. And that's because a const pointer is just like a const int. Where this guy has, you guessed it, internal linkage. Linker doesn't see unless we put extern. Okay. I have learned. Oh, well, yeah. If the pointer itself is const, bro, of course we can change what it's pointing at. That's the whole purpose of a const pointer. But a const pointer pointing at a const, neither can we change the value that it's pointing at, or change the object or place that it's pointing at. Can we change the value at the place it's pointing at? So we can't make it look anywhere else, but we also can't use it to change it. We can only use it to read it. Or copy it? Yeah, because I could say something equals a dereferenced version. Alright, I don't know if I've done it yet. Yeah, so I can assign something to the value that the pointer's pointing at, to the dereference pointer. A const pointer must be initialized upon definition, and it cannot be changed to point to something else. So it's initialized to be looking at x. It cannot be made to look at y. But we can still change what the value is. So sure, yeah. Pointer is unable to be looking at something else, but it's looking at x. X is modifiable, therefore we can modify x through the pointer. Cool. Yes. A const pointer to a const value. Yes. Const int pointer const. Holy shit. Can't change the value. Can't change what it's pointing at. Yep. No address nor value. Yep. It seems like that's another way of encapsulation. And I think encapsulation is the term where you have a like a constant global variable or something. And oh, hold on. Oh fuck, it scared me. Alright, I'm gonna have to pick up my groceries in a minute. Well, I'm gonna have to pick them up from the door, but I gotta get my ID because I got white wine coming, so I can cook, make some good chicken pasta. I have olives and shit coming too. This is about to be just disgusting. This shit's all self-explanatory. I haven't even read it yet, but I think it is. Const pointer to a const value cannot have its address. Yeah, okay. Oh yeah, it seems like it's the same way as encapsulating. So, excuse me, const expression value, internal linkage. Can't do shit with it elsewhere. Not included elsewhere. Only exists in the CPP file. Function get value returns that value. So you call that function to get it. Or const pointer, a const value pointer that is const. A const pointer to a const value. Yep. And in that case, we could, the music's going hard right now. I forget that you can't hear the music, so it probably looks like I'm tripping. Oh, nice. Okay. Yeah, I mean, I could call it, instead of a function that's a getter, the pointer's a getter, and I just dereference the pointer to get that value. And I can't change it. I can't dereference it. I can't reset the pointer. The pointer exists solely for that. But what would be the point of that? If it's a const expression value, it can't change anyway. So there'd be no point. I'm not sure the value of encapsulation, really. Oh, but maybe you want a changeable value that's changeable within this file and something that returns it but doesn't let you change it. So you don't want to access the value because it's changeable. Oh, so in that case, same thing. A const pointing const pointer. It treats the value as non-changeable, so you can't dereference it to change it, nor can you reset the pointer. So you're dereferencing a pointer. Maybe it makes more sense just to call get value. Feels like maybe that's the case. A non-const pointer can be assigned another address. Duh, because it's not const, and a const pointer probably can't. Oh, good. And it must be initialized upon initialization. Well, it must be initialized upon definition. A pointer to a non-const value can modify the value. Yes, exactly. And, well, yeah, it has to match the type of the value it's pointing to. It can't point to a pointer to a non-modifiable value cannot point, or to a modifiable value cannot point to a non-modifiable value, because then we can modify the non-modifiable value. Hello? A pointer to a const value treats it as const regardless of whether it's actually const or modifiable or not. Now we're chill. Fake news. Alright, here we go. Treats pointer to a const, treats the value as const, and thus does not change the value it's pointing to. And thus cannot change the value it is pointing to. These can be pointed to const or non-const values. Unless you give an R value an address via a const, an L value reference to const. These can be pointed to const or non-const values. Yes, true. Just like a reference can be a reference to a const, reference to an L value. That's not a reference to modifiable or non. It's fine. Const before, the type constant. Const after, constant, const pointer. Const pointer to a constant. That's easy peasy. A bit challenging. Bro, who are you writing this for? A const before the asterisk is associated with the type. Well, I mean, I guess this would be fucking gibberish if I know Python. Like, yo, what the fuck? I'm gonna pause for now.